In number 2, we get some practice evaluating logs. So in evaluating logs, it's important to be able to go from log to exponential function and vice versa. If we can convert a log to an exponential function, it is going to make our problem so much easier to solve, so much easier to think about. So let's practice doing that. If I have log, let's say base a of x is equal to y, then I can use my Ferris wheel, starting with the base a, drawing an arrow to the opposite side of the equal sign, that's going to be my exponent, is equal to x. So let me write that down again. This is the same as a to the y is equal to x, because when we're solving for a log, we're really just asking what exponent from the base will give me this value. Okay, so let's look at natural log of 1. So remember, natural log is just log base e. And so this question is really asking e to what power is equal to 1. And if we can figure out that exponent, then we have our answer. So we know anything to the power of 0 is equal to 1, which means natural log of 1 is equal to 0. That's it. Check. Okay, next, log 8 of 1 over 64. So this is saying that 8 to the power of what is equal to 1 over 64. So we can think about the relationship between 8 and 64. We know that 8 squared is equal to 64. Except, which would be good, except I have 64 in the denominator. It's 1 over 64. So remember, if we make an exponent negative, it moves the term into the denominator, becomes 1 over positive 8 squared, which would give me 1 over 64. So my answer is negative 2. All right, next one, log base 27 of 3. So this one is asking 27 to what power is equal to 3? Okay, so let's think. What's the relationship between 27 and 3? Well, let's think about it backwards. We know that 3 squared is equal to 9. What's 3 cubed? Well, 3 times 3 times 3 is 27. So I know that 3 cubed is equal to 27, but I want to know 27 to what power would give me 3. So how do I negate this? Well, if I take the cubed root of both sides, these guys would cancel, and I'm left with 3 is equal to the cubed root. Let me just rewrite that so it looks like a 3, the cubed root of 27. And remember, in problem 1, we learned that we can rewrite roots as exponents. So this would be 27 to the 1/3. So my answer is 1/3. Okay, moving along. Log, if it's not given to us, the base, we assume it to be base 10. So log base 10 of 0.001. This is really asking 10 to what power is equal to 0.001. Well, this would be a lot easier to think about if I wrote 0.001 as a fraction. Okay, and again, this is similar to this problem, the one with log base 8, because I'm dealing with denominators. So I just know that all that means is that my exponent will be negative. So 10 to what power would give me 1 over 1,000? Well, 10 cubed is equal to 1,000, so 10 to the minus 3 would give me 1 over 1,000. So my answer is a negative 3. Ding! All right, and then last up, natural log of the 6th root of e. So again, natural log is just log base e. In order to solve this one, I'm going to rewrite the 6th root as a fraction, as an exponent fraction. So it would be log base e of e to the 1/6. And we have a property that says if I take log base e, or of e to the 1/6, it's just equal to the exponent. So my answer is just 1/6.